Alright, number 82, we get a jet that's ready for takeoff. The engine supplies a constant thrust of this. How much runway will it need to reach its maximum takeoff speed? Okay, so let's get a little picture going here. Here's my jet. Here's my runway. It's accelerating. Okay, so there, and here's the tricky part. They give you two forces, and this is a question I get a lot. It says that there's a couple of forces going on here. The jet has a weight. The jet weighs 2.75 times 10 to the 6 newtons. That first part, that's telling you how much the jet actually weighs. And you know, the ground pushes back on that. It's the normal force. You don't know what that is yet, but the ground is lifting the jet at the exact same amount. 2.75 e to the 6 newtons. Now, there's also a force, the thrust. There's some force that's actually it tells you 6.35 times 10 to the 6 newtons. So that's the force that's rocketing it down the runway. Oh, baby, yeah. Sweet. And the question is, how much distance does it take to get up to, well, it needs to be going 285 kilometers per hour. So crap. We got this is a real doozy of a problem, because all right, we know it's starting from rest. Its final velocity needs to be 285 kilometers per hour. Now, this isn't going to do us any good. You got to put it in meters per second. So you're going to have to use your little dimensional analysis. So 1 hour is equal to 3,600 seconds. 1 kilometer is equal to 1,000 meters. So you take 285 times 1,000 divided by 3,600, and you get 79.2. So 79.2 meters per second. That's our final velocity that we need. The question wants distance, right? So these are the things that we're given, like right off the bat. Now, in order for us to get the distance, you got to know one other thing, and the only two other things are acceleration or time. Now, you're going to go with acceleration because you're going to use F equals ma, because they give you force, they give you the mass of the thing, so you're just going to crank through with the so we're actually not going to care about time. So our goal is to find the acceleration. Once we find the acceleration, we can run it through one of our equations, the one that doesn't involve time, and that's going to give us our distance. So let's see if we can figure out the acceleration. So F equals ma. Now, the force that is pulling our plane is this, the thrust force, 6.35 E6 newtons. So 6.35 times 10 to the 6 is the force. Now, the mass, this is the weight. It is not the mass of the plane, but you can find the mass by using F equals ma, because the force is 2.75 E6. We're looking for the mass, but the acceleration due to gravity is 9.8. So the mass of this plane is, you take 2.75 E6, and then you're going to divide it by 9.8, and you get 2.8 E5. 2.8 E5 kilograms. That's how much the mass of this plane is. So you take that mass, stick it in there, 2.8 E5 kilograms. And now you can find the acceleration, because there's a force pulling it forward. This plane has a mass, so force, mass, now we can find our acceleration. So 6.35 E6, we're going to divide by 2.8 E5, and you get 22.7 meters per second squared. 22.7 meters per second squared. So you stick that in there for your acceleration. 22.7 meters per second squared. Now you see why you can't use this, because I knew that my acceleration was going to come out being in meters per second squared, so you got to use meters per second. Now the one that doesn't involve time is this, Vf squared equals Vi squared plus 2AD. So now we're going to stick everything in. The final velocity, 79.2 squared. Initial velocity is 0. The acceleration is 22.7, and the distance d. So you take 79.2 and you square it, and then you divide by 2, and then divide by 22.7, and you get 138 meters. Looks like everything's got 3 significant figures, so yeah, everything they gave me 3. I think, yeah. So I think we can go with 138. Now this is a really awesome problem, because people in the Navy actually do it. They're called shooters. They're the people that are on the aircraft carriers. Each plane has its weight, and they have different weights for every missile and gun and round and how much gas it's got in it. So they know the mass of the plane, and they know what speed it needs to get up to actually take flight. So they enter in all these things on their catapults, but the distance is given to them on the aircraft carrier, because the aircraft carrier is only so long. So they have this little like trolley thing that hooks up to the plane and actually catapults it down the runway at a certain force. So they enter in all these things, and it's really just simple physics to figure out the force of the catapult, because you don't want to whip it too hard. You know, you put more, and if you whip it too slow, then it's going to fall off the end of the plane, and there goes $1 billion. So no, it's a really great problem.